All right, hello everyone.
Hi.
Hello.
Today we continue our journey here with 1.4, trying to calculate limits. And we did, I think 2 examples last class, and we started to see that some of the algebra is going to be a little bit challenging, I guess, is a word I could use. But before I do this, pick up from where we left off, I wanted to tell you that I have shared this page with you in Canvas. If you go to Canvas and you go to Files, in there you will find this document. It's called the Limit Summary. And I'm also going to send it to you right now in the chat, just in case you want to download it to your computer. So let me just grab this real quick. All right, so I just sent that through the chat also. Okay, so let me tell you a little bit about how this file works. So it's broken up into 4 sections here. And this is kind of a summary of what happens when we take a limit of something and we're getting certain things happening. What we're going to be focused, well, all we've talked about so far is this one case right here in yellow, when we take a limit and we get 0 over 0. Now, please understand, I'm talking about what happens when you take a limit. So don't confuse that with this. If I give you a function, let's say x squared minus 1 over x minus 1, if I were to ask you, what is f of 0, I'm sorry, not f of 0, what is f of 1, you would plug 1 in and you would get 0 over 0, and we would say that's undefined. That is not what this sheet is about. This sheet is about what happens if I take the limit as x approaches 1 of that function. So when we take a limit, the first thing we always try is direct substitution. So I'm going to try and plug 1 in. And when I plug 1 in, this limit goes to 0 over 0. That means we are in this yellow, we are in the case here of this yellow, all right? So I just want you to understand that there's a difference between talking about what happens while you're taking a limit versus what happens when you're actually just evaluating a function at a point. So I've had students before tell me, you know, well, 0 over 0 is undefined. I said, yes, I agree with you, but in the limit, we actually have to do some algebra or do a trick in order to figure out what's going on when we get 0 over 0. As we move along in this course, we're going to be looking at all these different cases. What happens when you get 0 on top, 0 on the bottom? What happens when you get infinity on the top and the bottom? What happens when you get 0 times infinity? What happens when you get infinity minus infinity? What happens when you get 1 raised to the infinity, 0 raised to the 0, infinity to 0? All of these are what we call indeterminate forms, which means we have to do some sort of algebra or some sort of trick. Today is just about this one, all right? We will slowly progress through all of these. And the rest of them, just ignore for now. Those will come later also, all right? But when we get through all this stuff, okay, when we finally get through everything, this sheet will be a nice little sheet you can refer to so that you remember what to do in what cases, all right?
Could we use it on the tests?
I'm going to let you use it on the test. Yeah, I'm going to let you use it on the test. So it's in Canvas, and I'll let you use it. But you also want to get to a point where you feel pretty comfortable. You don't want to have to refer to this for every single thing. Like everyone right now should know when you get 0 over 0, we got to do some algebra, okay? All right, so we're going to go to our first problem. So we're going to start working through, it's going to be a ton of examples today. And the reason why we're doing examples is so you can see the algebra that's required to do the problems. So here we go. Limit x approaches 2 of 1 over x squared minus 1/4 over x minus 2. So the first thing we do is try direct substitution. So direct substitution, I'm going to say DS for direct substitution. So when I do direct substitution, I plug 2 in, I get 1 over 2 squared minus 1 over 4 over 2 minus 2, and that's going to give me 1/4 minus 1/4 over 0, right? 2 minus 2 is 0, and the top is 0, so we get 0 over 0, right? So at this point, we know that we need to do some algebra or use a trick or something. Please do not be that person that takes the test and tells me that the answer here is 0 or undefined or something like that. That will get you very little credit, if any, all right? Because you're totally not getting what this is about, all right, if you give me one of those answers. So at this point, we said bad, all right, this is bad. So I need to do some algebra or maybe some trick. Okay, so the key thing to understand about this is that what's causing the problem, okay, what's causing the issue is the fact that we can't divide by 0. So it's this 0 down here that's causing the problem, which means that this x minus 2 is causing the problem. So our goal is to try and get rid of the x minus 2 by canceling it somehow. We need to somehow figure out a way to cancel it out. So one thing we could do, because we're looking at what's called a complex fraction, what I mean by that is I've got fractions over, right, another fraction. So we've got fractions within fractions. So we have a complex fraction here. So then the kind of rule of thumb to use here is to look at your numerator and try and combine those two together. So I'm going to get a common denominator and put those two together. And to do that, I'm going to rewrite the problem. Let me zoom out. I'm zoomed too far in here. Okay, yeah, there we go. So I'm going to take the limit. X approaches 2. Notice I wrote the limit again, right? I'm going to keep writing the limit over and over and over until I finally do a direct substitution at the end. Let me see. Let me just rewrite the problem first. If you have any questions, just stop me, okay? All right, so common denominator between those two fractions. They both have to have an x squared. They both have to have a 4. So I'm going to multiply the first fraction by 4 over 4. I'm going to multiply the second fraction by x squared over x squared. And that way, both denominators have 4x squared. Now I rewrite. Now when I put these two together there, multiply straight across, I get 4 over the common denominator. Then I have a minus sign, then I multiply those two straight across. I get x squared over the common denominator. And then all of that is still divided by x minus 2. Now that they have the same denominator, I'm going to rewrite it. Yes, I'm going to rewrite limit. I'm going to put those two together because they have the same denominator. So I get 4 take away x squared over the common denominator. All of that over x minus 2. And you know what? I think this is a good time to talk about something. I should have talked about this at the beginning, but let me just do this on the side so we can kind of get this out of the way right now. I want to know what this is. What is 12 over 4 over 2? So what's 12 divided by 4 divided by 2?
It's 3 over 2, isn't it?
3 over 2, that's one way you can look at it, right? Does everyone see that that could be, you know, you do this, 12 divided by 4 is 3, and then over 2 still. So 3 over 2 seems like a reasonable answer. Do you all agree? But someone else could have done this. Someone else could have said, let me do the 4 divided by 2 first, right? And that would give me 2. And then 12 divided by 2, well, that's 6. Well, they're not the same answer, are they? And we don't like math to work that way. So the way I wrote the problem down was wrong, okay? So when I wrote this down, this is not good notation on my part. What I would need to do was I would need to make one of the division bars bigger. So if I do this, okay, see how this second division bar is bigger? What that means is that you do this first and then you divide. And that would give you the 3/2. Now, if I wanted you to do it the other way, I'd write it like this. See the difference of where I put the long bar? So this would mean 4 divided by 2 first, then the 12 divided by that. And that would give you the 6. So the reason I'm saying that is because on this step right here, when I put these two together, right, and I put it here, notice how I made the division bar here longer? It's a subtle thing, but it's important to understand that it's this divided by this. It is not this divided by this fraction. Do you see the difference? Yes, we're good? Okay, so I'm trying to get the x minus 2 to somehow go away. Does anybody see something we can do? Does anybody recognize anything there? Something special that we may have looked at in college algebra?
Can't you do the x squared on the top and factor it out?
What, this 4 minus x squared?
Yeah.
That's a difference of squares. That's a difference of squares. So everyone should recognize that from college algebra, that that can be rewritten as 2 plus x times 2 minus x. Does everyone see that? Difference of squares? Now I'm just going to rewrite it. Limit x approaches 2. Okay, the top is 2 plus x. Then we have 2 minus x. Then we have the common denominator. And then a big division bar. And we have x minus 2. Okay. Now, please understand at this point that the x minus 2 in the denominator, you could look at it like a fraction over 1. And the reason I want you to understand that is because if we have something up here in this, like we have a top fraction and we have a bottom fraction. If there's something here in the numerator of the top fraction that could cancel with the numerator here, we can just cancel them out, okay? So do these cancel? So 2 plus x does not cancel with x minus 2, right? 2 minus x does not cancel with x minus 2 again, because they're almost the same, but they're not, right? Like this is positive 2, this is negative 2, this is negative x, this is positive x. So they're almost, right? They're almost able to cancel. So what can I do?
You can factor out a -1.
We can factor a -1 out. And I'm going to factor a -1 out of the numerator. Watch what I do here. I'm going to have the 2 plus x times, now here comes the -1 I'm pulling out. I'm pulling that one out of this one right here. So that will leave me with a -2 and then a plus x like that. And then all over the common denominator. And then all of that over the x minus 2. And again, I don't need to write it as a fraction, but I'm going to. And that's just to stress that anything up here, right, can cancel with anything here. So now these are the same, aren't they? They're not written exactly the same. They're written reversed order, but those two are the same exact thing. -2 plus x is the same as x minus 2. Do you all agree? And I can cancel it because, and this is important, I can cancel it because I have multiplication. These are all multiplications here. This is this times -1 times this, so then I can cancel the factor out like that. Boom. And at that step right there, we have now gotten ourselves rid of the problem, right? The problem was the x minus 2 in the bottom, and we have now canceled it out. So let's write down what's left. Limit x approaches 2. Okay, up top I still have a 2 plus x. I have a times -1. I'm just going to throw it right there. Then I have the common denominator below it. And then everything else that was down here is gone, right? Like this turned into a 1, that turned into a 1. So 1 over 1 is 1. So I don't need to write anything else. This is it. At this point, we will now let x go to 2. So we're going to now do direct substitution. So if I now take the limit, let x approach 2, I'm no longer going to write limit, okay, because I'm taking it now. This will become 2 plus 2 times -1 over 4 times 2 squared. So just replace all the x's with 2. So on top you get 2 plus 2 is 4, hit that with -1, so you get -4 on top. And then you square the 2 first. 2 squared is 4, and then 4 times 4 is 16. And now if I just reduce that fraction, I get negative 1/4. There we go. What do y'all think?
It's very fun.
Thank you, Danielle. At the end of the day, this is just algebra. Would y'all agree? This is, I mean, it's just algebra. But
Sí, señor.
there's a lot of little things, and it's like, you know, knowing that when you have a complex fraction, you try and get a common denominator, right? You need to know that. You need to know how to do that. Getting to this stage and seeing the difference of squares, like if you don't see that difference of squares, you're kind of stuck, right? Once you do that, then you have to see that these factors are just off by a sign, so you pull out a -1. Then they go away. So algebra, algebra, algebra. All right, I'm going to move to the next problem.
So real quick.
Yep.
When you get 0/0, like you did for that problem, do you always focus on the denominator?
You always focus on the thing. What you're always going to want is to get the thing that made this 0 to kind of go away. That's kind of the ultimate goal, is to get it to cancel out with something. Because once it's gone, then you no longer have division by 0.
Okay, so it can be either numerator or denominator that makes it a 0/0.
Well, the form we're looking at right now is anytime we get 0/0, right? So that's what we're looking at today, all right? 0/0. Once we see 0/0, our goal is to make the 0 on the bottom not be a problem anymore.
Okay, I understand.
Later on, we'll have different scenarios. So for now, that's where we are. All right, let's take a look at this one. So notice that we're using a different variable, t instead of x. Okay, no big deal. We're going to let t go to 4. We're going to see what happens. So first thing we do is direct substitution, right? So I replace all the t's with 4. So check for yourself, you do get 0/0. That's bad. Algebra time. So the thing that we're trying to get to go away is this. We need to somehow see if we can make that not be there and cancel it out. So anybody have any ideas of what we can do? I mean, it's just pretty much you got to try something here. Some sort of algebra.
Try to multiply it by itself, like with a conjugate.
The conjugate? Okay, so we did talk about this last time, right? Like when you see square roots, you might do conjugate. Let's do it, okay? Let's try it. So that means you're going to multiply the whole thing, right? You're going to multiply the whole thing here by the conjugate of the bottom, 2 plus root t, that's the conjugate, 2 plus root t. Everyone agree?
Mm-hmm.
Let's see what happens. All right, so I'll do the bottom. The bottom is actually, I think, a little easier. Well, t goes to 4. Okay, let's do the bottom. So when you multiply the bottom, it's like a FOIL, right? You're doing this times itself. And so the 2's hit each other, you get a 4. The middle 2 terms, we don't even need to write down. They're going to cancel, you know, always. That's the whole reason we use the conjugate. Can someone tell me what the last term's going to be when I multiply these 2 together?
T.
T. Plus t or minus t?
Minus t.
Minus t. Okay, so that's the bottom, right? Now on the top, do not multiply it through. Let's just leave it like this. Okay, let's just leave it like that. All right. Now you could check right now if you wanted to. If you try and plug 4 in, you're still going to get 0 to 0. It's still going to be bad, all right? So is there any algebra that I could do now? And by the way, I was taking Benjamin's suggestion of doing the conjugate here, but it's not necessarily, I never said this is going to work, okay? Right, so we're going to learn whether or not this works or not.
You could factor out a p from the numerator.
Yeah, good. So does everyone see that right here in this expression right there, you could factor a t out? So let's pull the t out. If we pull a t out, we're going to be left with 4 minus t. And hey, check that out. 4 minus t, right? Won't those cancel? And that means we have limit t approaches 4. Now let's see what's left. I rewrote that. So I still have the t, right? I still have this thing, 2 plus root t. And the denominator, oh, well, that all canceled out, didn't it? So I don't need to write anything else, but I mean, like, you do have a 1 down there if you want it. I mean, it's a 1, it's gone. Now at this point, let's try direct substitution. Let's see what happens. So I'm not going to write the limit now. I'm going to let t go to 4. And I should just get 4 and then 2 plus root 4, sorry. And that means 4 times 2 plus 2. 2 plus 2 is 4, so 4 times 4 is 16. So the limit is 16. It worked. It worked. Now, I want us to not lose sight of what we're doing here. All right, so take a look at this. And we're trying to figure out what happens when t goes to 4. I'm going to bring up my graphing software real quick. Not my graphing software. I'm going to go to Desmos again, which is my current favorite graphing software or graphing website. And I'm going to type this thing in, but I'm going to use x's instead of t's, okay? So 4t minus t squared, so 4x minus x squared, and then over 2, what was it, minus the square root of x. Okay, so here's the graph of this as a function. What we're asking ourselves is what happens as we approach 4 from both sides, right? That's what the limit means. And if we look at this graph, here's 4. I don't know if I can get it all on one screen. I don't think I can. To zoom out a little bit. Okay, so here's 4. Here's 4. And if we go up to this function, what is the value of the function at 4? If I ask you to plug 4 into this function, what are you going to get?
16.
Nope. If I tell you to plug 4 into the function, what are you going to get?
0.
0 over 0, right? Which is undefined, which means there's actually a hole in this graph. Remember, the graphing software doesn't show you the hole. Okay, so it's 2021, and this graph thing still doesn't show holes in graphs. Maybe next year, who knows? But right now, we know that there's a hole, right? We know there's a hole. Now, we took the limit, and we found out that as you come in from the left and you come in from the right, those y values are approaching 16, right? We did that without ever looking at the picture, right? That's what we did. So if you think about it, it's like if you just kind of step back and say, okay, look, let's imagine this is a function. I ask you to plug in 4. Everyone's going to go, oh, 0 over 0, that's undefined. I'd say, okay, yeah, that's fine. But what's happening near 4? Well, you can't really answer that because you don't know anything until you do the limit. Once you do the limit, then you know what's happening near 4, right? Okay, now I want to do this problem a different way, all right? We're going to do the same problem, I'm going to do it a different way. There's nothing wrong with that way, but I want to show you that there's multiple correct paths here. So I'm going to start out with the original problem. And what I'm going to do is I'm going to start out by factoring out that t. I think Austin had suggested that right here in this step, but I'm not going to bring the conjugate in. So I'm just going to factor a t out. So if I pull a t out, I'm left with 4 minus t. Then on the bottom, I'm left with 2 minus root t. All right, and if I do that, nothing cancels, okay? Nothing cancels out yet. Now, because I'm a Cal 1 student and I'm pretty good at algebra, or I'm getting better at algebra, I realize, like, I really want this to go away, right? But I realize that this 4 minus t, if I kind of squint my eyes enough, I could do a difference of squares on this. I could write this as 2 plus root t, 2 minus root t. And I showed you this earlier in the semester. I said, you know, we're doing algebra on steroids. This sort of algebra is not natural in college algebra, but here, this sort of algebra is definitely fair. Does everyone agree that this is this? All right, you just FOIL it out. That's 4. The middle terms go away, and you'll get root t times negative root t. That's negative t. So that is true. So if I do that, come up here and replace this with the 2 plus root t, 2 minus root t. Now I get the cancellation right off the bat, right there.
You do it the other way too, by squaring the bottom half, or no?
What do you mean?
You know the bottom half, the 2 minus square root of t. Can you square that to equal 4 minus t?
You can't square it because, well, first of all, you can't just take a fraction and square it like whenever you want to. You can always square both sides of an equation, but you can't just take an expression and square it.
Okay.
Okay, but even if I did square this, if you take 2 minus root t times 2 minus root t, it does not equal 4 minus t because you have to have different signs here in the middle in order for those middle terms to go away.
Okay. Thank you.
Okay, good questions. Okay, so limit t goes to 4. Let me just rewrite what we have. Only thing left here is t and then 2 plus root t. And if you look, that's the same thing we had right there. Well, yeah, right there. And so we're gonna get the same answer. So that's just to show you 2 completely different algebraic approaches, right? Not every problem is gonna have 2 paths, 3 paths. Some problems only really have one way to go, but this is an example of one where you could do it different ways, depending on how you see it. I think that's what starts to make calculus difficult, is the fact that most of what you've done in your life in math, there's been like a path that's been made very clear to you. Like if you're going to solve a quadratic equation, you use a quadratic formula, you know, and it's very, very direct. You get from point A to point B and you're shown how to do it and then you do it. Here, you know where you need to go, but the path that you choose is really going to be determined by your comfort level with algebra and just how good you feel about manipulating expressions. Here's the next one. So I've done 2 now, so now I'm gonna start calling on people because I want to make sure everyone understands the steps, like, you know, what we're doing. So Laura, you're up first today. Are you here? All right, Laura, so what's the first thing you're gonna do?
I would first try direct substitution.
Okay, so you're gonna be replacing what with what?
Replace h with 0.
Okay, so be careful, everyone, because even though there's x's in this expression, the limit has h going to 0, right? Okay, so we replace h with 0. we do that, we should just get x plus x plus 0 cubed minus x cubed over 0. And x plus 0 is just x, so that's x cubed minus x cubed on top over 0. And that's 0 over 0. Right, Laura? Okay, so this is bad. We're going to do some algebra. Algebra, whatever. Trick. All right. Hey, Laura, what is it that we're hoping is going to go away once we do some algebra?
The h in the denominator.
That's right. We're hoping we can do something algebraically to make that h go away, right? Okay, good. So Claire is up. Oh, wait, hold on a second. I've got some people I've only called on once. Let's go with Vivian.
Yes.
You there? Okay. All right, so Vivian, any algebra, anything you can think of. Vivian, have you ever played any sports?
Yes, I did.
What sports have you played?
I ran track in high school.
Track?
Yes.
What kind of track did you run? Like short distance, long distance, hurdles? What did you do?
I did short distance.
Short distance?
Yeah.
Yeah, so when you get up there to the start line, right?
Mm-hmm.
Like you just, at some point you just have to go, right? Like usually they'll give you a signal, right? They'll shoot a gun or something or sound and you go, right?
Yeah.
Okay, so what you don't do is just stand there, right?
Yeah.
So I've given you the go. So you've got to do some algebra. I don't care what it is, just do something. Move forward. And don't second guess yourself. Just give me something algebraically that I can do here.
Could you do the cube root?
Like cube root everything? Is that what you're saying?
Yeah.
Are you trying to get rid of these threes? Is that what you're trying to do?
Yeah.
Okay. So this goes back to what I was talking about last class and a little bit today. When you have an expression, you cannot just square it. You can't just take the square root. You can't just take the cube root. It changes the problem. You can only do that when you have an equation. You work on both sides of the equation. So, okay, you took a step forward, Vivian, and that's all I want is for you to take a step forward. Now, it's not going to get us anywhere, but you have to be willing to take a step, okay? Because if you don't take a step, you just get stuck. So let me help you, Vivian.
Okay.
All right. H is just H. There's not a whole lot you can do with that, right? H is H. And x cubed is just x cubed, because you don't know what x is, right? It's just x cubed. Yeah?
Yeah.
But x plus h cubed really means x plus h times x plus h times x plus h, doesn't it?
Yeah.
So why don't we just do that? Maybe it'll get us to the finish line, right? So
Yeah.
on the side here, I'm going to do x plus h times x plus h times x plus h. I'm just going to do it, all right? Because we have to do something. All right, now I don't want to go through all of this. I'm just going to show you what the next lines would be. Vivian, you're off the hook.
Okay.
X plus h. These two together give us x squared plus 2xh plus h squared. So I just FOILed this out and collected like terms, which I expect everyone here could do. And then I'm going to distribute the x through and then the h through. And when I'm done with that, I'm going to get this. So I'm skipping some steps here, but I hope that you know you could do this if I gave you enough time. You could expand this all out and get this, okay? Is that all right for me to do that? Just let you have that on your own?
Yes.
Okay. Now, what I'm going to do, rewrite this, limit, h goes to 0, and then we pretty much expanded that out, and it all became this. So I'm just going to write that all there, x cubed plus 3x squared h plus 3xh squared plus h cubed. Okay, that's just this piece right here. I still have up there, though, minus x cubed. And on the bottom, I still have over h. All right. Gabriel? Is Gabriel here? Uh-oh. Dun, dun, dun. Okay. Axel?
Yes, sir.
Okay, Axel. You see anything? Look at the numerator.
The H3 or the
Professor, quick question before we move on. I'm
Yeah.
a little confused why it's 3x squared h and it wouldn't just stay as 2x squared
Well,
h.
you need to actually do this multiplication. So you have to do x times x, that gives you x cubed.
Mhm.
Then x times that gives you plus 2x squared h. And then the next one gives you xh squared. Then you start working with the h here. So h goes right there, and you get h times x squared. And you can see here that 2x squared h can be added to hx squared, and that gives you 3 of them.
Okay. Okay.
And then I didn't finish, but there's more terms, and then it all collects together. So I skipped from here to here because I've done it thousands of
Yeah,
times.
so I was confused why it went up to 3 and didn't stay at 2.
No.
But now I understand.
Okay.
Thank you.
And please, everyone, ask a question, okay? I mean, there's no harm in asking a question. All right, so Axel, do you see anything good? Or any of those like terms?
oh yeah, sorry. The X3s cancel.
X cubes cancel. And that just about saves the day, okay? Because watch what happens now. Everything that we have left, everything that's up there in the numerator. Axel, what does every term in the numerator have in it?
An H.
An H, which means I can factor an H out, right? So let's factor a single factor of H out of the denominator. I mean, sorry, numerator. So I'm going to pull an H from here, an H from here, and an H from here. So here comes the H out the front. We have 3x squared. We have plus 3xh, and then plus h squared. All of that is divided by h. And that's what we were hoping for, right? We wanted the h to go away, and we were able to get that h out so we can kill it off.
Yes.
Good. All right, Axel, you're off the hook. So Daniela.
Yep.
Daniela.
Oh, my bad.
Sorry.
Here.
Daniela.
I'm here. Sorry.
Daniela, we've got the bad thing to go away, right? The H that we wanted to get rid of. So what now?
Yeah. Do you replace the 0 in the
Yeah. So now we do the direct substitution. We take the limit. We do the direct substitution. We no longer write limit, okay? And we're replacing all of the H's with 0. So we're going to get 3x squared plus
Oh yeah, the H.
0
Sorry.
plus 0 squared. So I just replace these H's with zeros. And when that's all said and done, I just get 3x squared. Now, this is the first time we've done a limit and our answer was not a number. Do y'all agree that our answer is just an expression, 3x squared? Everything else has been a number, and that's because the original limit had 2 variables in it. One of them was going to 0, so the h went away, but the x is still going to be in our answer. It's got to be somewhere, and here it is, 3x squared. All right, so just looking back at this again, 0 over 0 bad, do some algebra. We looked at this. So, what can we do? Well, the only thing we really can do is just expand that out. We did, and then, voila, the x cubes cancel. And then everything here had an h, and it was just all worked out from there. So was it Vivian? Was Vivian the one that earlier, the track star, right? Do you see, Vivian, now that, I mean, you just have to do something, right? You just have to be willing to take a step and try something, right?
Yes.
Okay. And trust me, you will get better at this, okay, with practice, all right? You will get better. It's going to take a while, though. It's impossible for me to show you every type of problem you could ever see. Like, every problem is going to be different. So the more practice you have, the more comfortable you get, and you do better. All right, here we go. So let's see, Javier, you're up. You know what? I'm gonna call on Javier, but I want to give everybody, I don't know, I'm gonna give everyone about 5 minutes just to start seeing how far you can get with this, and then I'll interrupt everyone and I'll take it the rest of the way. All right, so 5 minutes. One more minute. Okay, that's time. I'm not saying you should be done. I'm just, we got to continue. So Javier, did you get anywhere with this?
So the first thing I did was I decided that like I recognize that the denominator is the issue here. So what I did is I multiplied the numerator and the denominator by the conjugate of
What is the
Five.
conjugate? What is the conjugate?
5 plus the square root of x squared plus 9.
Good. So everyone just be aware the conjugate, the x squared plus 9 doesn't change. What changes is the sign between them changes to a plus. Very good. That's exactly what I would have done also. All right, what did you do next? I mean, you multiplied. Did you actually expand out the bottom? Did you like figure out what all this is?
I think so. So the first thing I did, I think for the bottom, I ended up getting a 25 minus x squared plus 9 because both of the square roots combined makes it into you can basically remove it at that point.
Yep. Okay, so this is good, but I would need to be very clear on something. What I've written here is not correct, so let's just be sure we understand this. You do the 5 times 5, that gives you the 25. The middle terms go away, so you don't have to worry about it. So all you have to worry about is this times this. Now, one of them's negative, one of them's positive, so I know my answer is going to be negative. But it's this times this, so the square root goes away, right?
Right.
So you're left with x squared plus 9. So this must be in parentheses.
Okay. Oh, okay.
Okay. Now, in the numerator, I'm not going to do anything. And you know what, Javier, you did great. That's all I needed. Did anybody else, I'll call in a volunteer, did anybody else get to this step and continue? Anyone?
I just got there.
You got to there? Okay, so here's where we are. All right, you ready for the next step? Let's clean this up. What is this? What's 25 take away x squared? And then you could distribute the negative through, make that a minus 9. What would that turn into down there?
You can the difference of squares into x plus 3, x minus 3 within the parentheses, right?
Oh, in here?
Yeah.
You can't, yeah, be careful, Benjamin, because we could do that if that was a minus,
Oh, okay.
but it's not, right? It's a plus. So what I'm suggesting is why don't we distribute the negative through? Just make that negative and then make that minus. And what you get, I'll write it here. That's what you get if you distribute the negative through. Now let's do 25 minus 9, that's 16. You with me on that? So we have 16 take away x squared. Any questions? Better? Better? I don't know. Am I doing that? Am I saying that right?
Yes, Adair.
Adair. See, I keep on
Adair.
trying to.
It's like the way you remember is like I dare you to, just add an E, Adair.
You know what? I'm going to write that here. Adair. Adair. Okay, there we go.
Yes.
All right, Adair.
From here.
You okay up to this point? Like, have you followed?
Yes, I just caught up. I was stuck on the previous step when we were doing it on our own, but
Okay.
I feel like I'm pretty caught up now.
Okay.
So on the denominator, we can do a difference of squares, which will give us 4 minus x and 4 plus x.
Perfect. Great. Everyone see that? And that's going to allow the 4 minus x to go away. And that's probably going to solve the problem as far as we shouldn't have a division by 0 anymore. Let's see. So in the numerator, you're left with 5 plus x squared plus 9, because the 4 minus x went away. And on the bottom, you still have the 4 plus x. And now we can go ahead and let x go to 4. So no more limit. I'm just going to start writing things. 5 plus square root of 4 squared plus 9 all over 4 plus 4, which is, let's see, that's 16 plus 9 is 25, and then square root of 25 is 5. So the top should be 10, and the bottom should be 8, which is really 5/4 if we reduce it. There we go. 5/4. See, it's algebra, right? It's what I promised you. And trust me, calculus will deliver. It will deliver you algebra consistently. All right, now, I mean, we could spend the next 3 months doing limit problems, right? I mean, there's no limit, no pun intended. There's no limit to how many problems you can do. I mean, there's no such thing as doing too much practice when it comes to limits. So I'm gonna open up your the electronic version of the book, because I want you to kind of see what your homework assignment looks like. We're not done for the day, okay, we're not. But I just want you to see for this part where we are. Oh, I'm in the wrong chapter, sorry. Here we go. Where is it? How do I get out of here? Okay, here we go. We're in 1, and then we are in 1.4 exercises. Okay, here we go. So I have assigned for 1.4, 1, 2, 5, 9, 12, 14, 15, 16, 18, all these problems, right? Look at this, like 12 through 20. I mean, there's a lot of problems there, isn't there? And if you look at this, it's pretty much like from here, like 12, it's a lot of these. My recommendation to you is that you make an honest attempt to try and do numbers 11 through 27, or go to 28. Now, remember, I have solution videos out there for you. If you get stuck, you can watch my video. But if you can do these problems, you're going to see all sorts of different little algebra things in there. All right? But there's no way that you can just look at 4 examples I do in class and be like, yep, got it, ready for the test. All right? There's no way. Okay. We're going to continue. We're still in the same section. All right? We have not moved into the next section yet. All right, so there are 2 very important limits that I'm going to tell you what the limits are, and I'm not going to show you why these limits are equal to what they're equal to. Okay, so the first limit here is the limit as x goes to 0 of sine of x over x. Now, you can also flip it around and make it x over sine x. It doesn't matter which order these are in. The limit will always be 1. Please memorize this. I'm not real big on memorization, but this is one of those ones you should memorize. So just so you are aware of what's happening graphically, if we take the graph of sine of x divided by x, here's the graph. Now, you can't plug 0 into this, because if you plug in 0, you get division by 0. So there is a hole here. There's a hole there. But hopefully you can agree with me that from the left and from the right, the limit is 1. It's approaching 1 from both sides, okay? So for right now, you're going to take that on faith, okay? I'm telling you, you look at the graph, you say yes. But there's no algebra or trick that I can show you right now to prove to you that this is true. In other words, I can tell you right now that this is 1. But I can't show you why. Okay, so I can't do any algebra or any trick on this right now to convince you. So you just have to believe me, okay? Believe me, please. Now the other limit, it's not used as much, but you should know it, is the limit as x goes to 0 of cosine x minus 1 over x. If you try direct substitution here, this right here, cosine of 0 from pre-cal is 1. So what you wind up getting is 1 minus 1, which is 0, so you get 0 on top, and then you get 0 on the bottom. So it's an indeterminate form. We have to do some algebra, some trick. I can't tell you what that is or show it to you right now. You just need to understand that the answer is 0. All right?
We treat it like an identity from trig?
Yeah, it's like, just take it as a formula, okay? It's just like, this is the way it is, and don't ask me why, right? Like that's now later on, I'll show you why. So for now, just accept it, but later on, I'll actually prove it to you, okay? Now, in all my years of teaching this can be very confusing to students than the thing we're about to do. So I like to present this formula in a slightly different manner, because this one is this is the most important formula for today, right? For these, out of these two, this is the most important one. So I'm going to present that to you in a different way. If you ever have a limit, okay, let's say you have a limit, and let's say x is approaching something. I don't even want you to care about what it's approaching. X could be approaching 1, it could be approaching 2, it could be approaching 0, it doesn't matter, okay? But x is approaching something. And then on top you have sine, and inside that you have some junk. And when I say junk, I mean, I don't know, it's something, okay? It's just some junk in there. It could be x squared, could be x cubed minus 1, doesn't matter, something, okay? And then that's divided by the exact same junk. Then this limit is going to equal 1 if, first of all, the junk is going to 0 and the junk matches. And all I mean by that is the junk up top better be exactly the same as the junk on the bottom. Now, I know that's weird, so you're like, what is he talking about? Let me just show you an example, okay? Let me show you an example. So I'm going to leave that up there. As an example, let's say I give you the limit as x approaches 5 of sine of x minus 5 over x minus 5. All right, so you look at that, and what you should notice is that we have sine of junk over junk, right? These two junks match, don't they? They're exactly the same, x minus 5, x minus 5. And if I let x go to 5, don't these go to 0? Doesn't that go to 0? So not only do we have that the junk matches, we have that the junk goes to 0. So what can you tell me the answer is?
1.
1. Okay, there's no work. You just have to make sure that it looks right, and then you can conclude that. Okay? Let me show you another example. Let me do it next to it, and I'll do a different color.
What if they don't match?
Yeah, okay. So let me try this. All right. If x goes to 5, does everyone agree that this right here goes to 0? No? Does everyone agree that this also goes to 0? Because 5 squared minus 25 is also headed to 0. So our junk is going to 0. This junk right here is going to 0. But does it match the junk on the bottom? Are these the same?
A little bit.
A little bit, but they're not exactly the same, right? And therefore, you can't tell me that the limit is 1. All right, it has to match exactly. You with me?
Yes.
Okay, all right, but we're not done. Watch. Here's what I can do though. You just tell me whether or not you agree or disagree with this. You can realize that the bottom is a difference of squares, right? That is a difference of squares. And now, watch this. What I did here is just basically algebra, but backwards. If you ever have two fractions and you want to multiply them together, you just multiply straight across, right? So you just go 1 times this, which would give you that, and then this times this, which is this, right? So what I've done is I pulled them apart, haven't I? And by pulling them apart, now what I can do is I can take the limit of each one individually. I can look at this as 2 separate problems. And that came from the limit laws that we learned last class. It said if you ever have a limit of something times something, and there is multiplication here, then you can just look at the limit of each one individually. So what is the limit of this one as x goes to 5, do a direct substitution into this, and what would you get?
110.
110? Okay, times, now this one, what is that limit?
1.
Because that's this problem, right? Junk matches, junk goes to 0, so that's 1, and so your answer is 1/10. Questions? All right, here we go. Limit x goes to 0, sine x over 5x. So if we try direct substitution right now, if we did direct substitution, we get sine of 0 over 5 times 0 is 0. Everyone here knows sine of 0 is 0, so we get 0 over 0, this is bad. But there's no algebra trick we can use because we haven't done anything like this. So the only thing we can use is that thing that I just presented you with, which is this right here. Well, hold on. Right? That's all we can use. So let's see, do we have what we need? Limit x approaches 0, we have sine of x over 5x. So Benjamin, I know you've been participating already, but your name's up. So
So can you use trig identities or no?
well, just tell me, do you have sine of junk over junk?
Kind of.
Here's junk, that's the junk, right?
Yeah.
It's got to be x. Now, we don't have x on the bottom, we have 5x, don't we?
Mm-hmm.
Is there something you can do algebraically to separate the 5 from the x?
You can do that division thing you did last time, I think. The 1 over 5 times.
Yeah. Yep, 1 over 5 times sine of x over x, right? We can do that. And just split it apart. And now take the limit. So let x go to 0 now, Benjamin. This and this, where do they go?
It's going to be 1/5.
Times
1,
1, which means we get 1.
1/5.
There we go. We're done. So this was recognizing that in order to get the junk to match, we had to kind of peel the 5 off to the front. Any questions? Let's look at the next one. The next one's not the same. It looks the same, but it's not. So Ryan, is Ryan around?
Ryan or
Ryan, Ryan Medina is what I have here.
Yes.
Okay. So Ryan, direct substitution, Ryan, right? Direct substitution, let 0 go in there. You get sine of 5 times 0. That's what that really means. And then over 0, sine of 0, 0. So you get 0, 0, right?
Yeah. Yes.
Okay. Now, what's the junk, Ryan? What is the junk? Junk, doesn't matter. What's the junk we have?
The x or the 5? Do you mean?
Well, that's what I'm asking you. We'll always look at the junk as being the stuff in the sine function. Okay, maybe I didn't stress that enough, but so for us, the junk is going to be the 5x. Okay.
Yes.
Now, do we have the junk on the bottom?
No.
No, right? It's just x, not 5x. Agreed?
Yes.
If it was 5x, you'd be done, wouldn't you?
Yes.
All right. So Ryan, can you think of any way that you could force it to be 5x? This is tricky.
You're talking about the bottom to be 5x?
I want it to be 5x. Can you make that a 5x?
I don't know how.
Well, you'd have to multiply by what?
5.
5, but you can't just multiply the bottom by 5. You'd have to do what else?
Multiply both sides, up and down.
Top and bottom, right? So why don't we, so look, everyone understand right now that Ryan really wishes that this was a 5x, right? And so Ryan's going to force it to happen by multiplying by 1. And the 1 is going to be a 5 over 5. Now, I know that seems weird and it seems like we're cheating, but we're not. That's a 1. Now, the next line is going to look like this. So basically that 5 right here, we just stuffed it underneath this fraction and left this 5 that was here on top over 1. Do we all agree this is the same thing? All right? And this is the same thing, isn't it?
I think you read the x on the bottom.
What's that?
The x on the denominator.
Oh, I forgot the x. Yes, I apologize. Thank you. That's my fault. I forgot the x. Yeah, that x was there. I just slid the 5 underneath, next to it like that. This is equal to this. Now, Ryan, if I do the limit, what does this go to? Now that the junk matches, right?
Right.
Where does this whole thing go?
To 1?
1, okay. Times, now we still have this, right?
Yeah, so times 5.
5. 1 times 5 is 5. So the answer is 5. So this problem is different than the last one because we had to introduce this, right? We had to like come in there with that 5 over 5 to make things work the way we wanted to. Now, I know somebody's probably sitting there asking themselves or wants to ask, why didn't we just take this 5 and pull the 5 out?
Yeah, that's what I was gonna say. That's what I was wondering.
Yeah.
Sine 5, right?
The reason you can't do that is because that's not the way sine functions work. That's not the way trig functions work. You can't pull numbers out. You just can't factor a number out of, whenever you have a trig function, whatever's in here is called the argument of that function. And if you have a number in here, let's say like 5x, you are never allowed to pull that number out, ever. Okay, so Because of that, we couldn't do anything but try and make the x on the bottom become 5x. And that means we forced that to happen. All right, these are just going to get weirder and weirder. All right, here we go. Yeah, we'll do this one. How are we doing on time? Oh. Is Mustafa around? No? Okay. Gene? Gene? No? Gene? No Gene. Okay. Austin?
Sorry, I'm here.
You're there? Okay. All right. So Gene, are you following? Okay.
Yes.
Okay.
I figure you do something similar to the last one, right?
Okay, but we don't have a sign.
Oh, right.
But tangent does have something to do with sine, doesn't it?
Mm-hmm.
How could I get a sign in here? How can we rewrite tangent of 5x?
You can rewrite it as... I forgot exactly what it was. We learned this in trig, right?
Mm-hmm. So tangent, everyone, tangent of something is the same as sine of it over cosine, right? Sine over cosine. So
right.
Watch what I'm going to do, everyone. I'm going to rewrite tangent of 5x as sine of 5x over cosine of 5x, and then times 1 over x. So just, maybe I should have shown this step. I'm rewriting tangent of 5x over x as this over 1 times 1 over x. So I'm just sliding the x to the side so I can rewrite the tangent 5x as sine over cosine. Y'all okay with that? Any questions? Okay. I want to highlight something. That's what's causing the problem, right? When I take the limit as x goes to 0, this is what's giving me division by 0, right there. Right? That's the problem. I want to get it to somehow not be division by 0. So I'm going to open this up to the class. This is a weird problem if you've never seen something like this before. Does anyone have an idea of how we might be able to go about this using this whole sine junk over junk thing?
Multiplied by the reciprocal?
The reciprocal of what?
1 over x? Oh no, never mind, that wouldn't work.
Could you multiply top and bottom by 5?
Okay, so you're trying to get a 5 in there?
Yes.
Okay, uh-oh, hold on. I just lost my pen. It's back, but it's on the wrong screen. Hold on.
Can we just try to get rid of x right there?
Hang tight. I don't know why it does that every once in a while. It's weird. Okay, I think I'm back. Okay, so what I'm hearing, I think it was Elise said, why don't we do what we did last time? We multiply by a 5 over 5. And that would allow me to slide this 5 right here and make that a 5x. Do you all agree with that? I could do that? But how does that help? I want to make sure everyone understands this is correct, but I want everyone to understand why this is going to be okay. Like, what am I going to be able to do now?
That with the sine of 5x is just equal to 1.
That's right. So look, if I take the sine of 5x, that's right there, and let me rewrite it with the 5x underneath it, and then let me slide the cosine out to the side, and then leave the 5 that was still on top where it was. So what I'm doing is I'm using the property of multiplication that you're allowed to move things around, which is called the commutative property of multiplication. I am getting this cosine out of here, so I'm moving it to the side. I'm leaving this 5 here, but I'm taking the 5 that was on the bottom, putting it next to the x, and then moving all of that underneath the sine 5x. Does everyone see all that weird stuff happening? This was Elisa's idea. So don't blame it on me. But it's going to work, right? This, now when we take the limit, where's that going to go?
1.
Okay. Times, now real careful here, cosine of 5 times 0. Cosine of 5 times 0 is cosine of 0, and cosine of 0 is 1. Cosine of 0 is 1. So this is just becoming 1 over 1. That's what this one is. And then times 5. So at the end of all of this, the answer is just 5. I'm gonna recap the problem. We had tangent 5x over x. If you were to take direct substitution, you would get division by 0. So we split the x off to the side so we could rewrite tangent as sine over cosine. Then we realized that we had assigned 5x up here, so we knew that we were going to need a 5x on the bottom, so we made the 5x happen by doing 5 over 5 and sliding the 5 over. Then we took the 5x, slid it under the sign, peeled the cosine off to the side, left the 5 here, took the limit, boom, we got 5. So if you're not having fun yet, then you're never going to have fun. I'm kidding, of course. All right, let's do another one. Gonna make this one up.
Hey, Professor.
Yes.
I'm not sure if that's right or wrong, but we just did 3 problems for this one, right? So every single time we see anything on the top, like whatever number, those are the answers we're getting.
Oh.
At the end.
Yeah, be careful. That won't always work that way. I know what you're saying. Yeah, what you're saying is that like this was 5, the answer was 5. The previous problem was 5 here, the answer was 5. Yeah, no. This one right here was a 5 on the bottom, so the answer is 1/5. Not always going to work that way. I'll give you an example after this one.
Okay, great. Thank you.
Okay. Okay, here we go. Sine of 3x over sine of 5x. So if you let x go to 0 right now, direct substitution, you're going to get 0 over 0. Okay, that's what you're going to get. So the piece that's causing the problem is this. That's causing the division by 0. So Claire? Is Claire here?
Yes.
Hey, Claire.
Hi.
If I wanted the sine of 5x to not be a problem, what could I put on the top so that it would become a 1? So remember, and I'm going to remind Claire and everyone that when I gave you this formula, sine junk over junk, that came from this right here. But do you remember I said it could be flipped over?
Yes.
Okay, so you could rewrite this the other way around. Sine junk on the bottom, junk on the top. So back to my question. If the yellow's causing the problem, Claire, what would we really love to see up top to make it not be a problem?
A 5x.
A 5x. A 5x, right? Does everyone agree with that? 5x. Okay. Now you can't steal an x out of here because it's trapped in the sign. You can't, you're not allowed to do that. So Claire, you want a 5x? I give you 5x. Here it is. I put it up here on top. Now you'll be happy, except for the fact that you can't just throw a 5x in there. You have to put a 5x on the bottom too, right? You have to do
It's
whatever.
just a 5x, not sine of 5x, right?
No, just 5x. Just 5x. Okay, so let's see. Hope everyone's following this. This right here, that basically looks like junk over sine junk. And both the junks match exactly, and the junk is going to 0, so the answer should be 1. Okay, because it doesn't matter if the sign's on top or bottom, all right? So does everyone see that Claire has fixed the problem by introducing that 5x? Okay, but you don't get anything for free in this world, right? Well, sometimes. They say that, but I think nowadays you do get some things free. All right, so there was a give and a take here. Claire fixed the problem, but she also created a problem. Do you all see the problem she created? What is it?
We have a 5x left over in the denominator.
Yeah, look at this 5x now. If you let x go to 0, that's going to go to 0. You're still going to have division by 0. So it's like you're on a boat and it's leaking and you're like patching up the leak, and as soon as you patch up the leak, there's another leak over here, right? That's what happened here. Y'all with me? So how can we fix that? How can we make that 5x not be a problem?
Could we multiply everything by a 3x over 3x and then essentially just have 3x over 5x left?
Yes. Okay. So let me do something. Austin's on the right path here, but I'm going to present it in a slightly different manner. Let me just rewrite everything the way we have it. Okay. So I'm just going to slide things around. So all I've done here is I took this 5x over sine 5x, put it here because we know that that's going to go to 1. Okay, so we're not worried about that. And then I have this sine 3x that was still there. I've just put that over 1, and then I still have the 5x on the bottom and put that right here. Everyone good with that? What Austin is suggesting is why not put a 3x here, right? Because then this would become a 1. I agree, but I want to kind of see, I want everyone to kind of see it a different way. I don't want to throw a 3x here because it'll become a 1. This isn't the problem. The problem is the 5x. That's the division by 0. So what I'm going to do, with the way I want to kind of have you perceive this, is I'm going to take the x and stick it under this, okay? And then I'm going to introduce a 3 over 3 and slide the 3 underneath with the x. So what I'm doing is I'm using this x against itself. I'm saying, okay, you want to be x? Fine, I'll bring you under here. I'll tack a 3 onto you, and then now this thing's going to go to 1, but you no longer have the division by 0. Look, if this seems really like weird, like this is some weird shit, it's because it is weird shit, all right? Like if this is the first time you're seeing this, this is strange stuff, all right? But this is a level of thinking that goes way beyond algebra and pre-cal. Like this is another way of thinking. Question is, can your brain think this way, right? All right, so here we go. Rewrite everything. Got 5x here, sine 5x times, okay, now I've sine 3x here. And then here, what did I do? I just pulled just the x in the 3. There it is. So what's still here? What's still out here? If I pull the x and the 3 out, what do I still have here?
3/5.
Yeah, I have 1/5 here, and then over here I have 3, and I pulled that 3 off the bottom, so I still have 3 over 1. So yes, that's 3/5. Now, Austin, what you were suggesting that we do 3x on top and bottom would have also worked. Okay, I'm not saying it wouldn't have, but I'm trying to get everyone to see that we're trying to like plug the holes in the boat. And so I'm trying to plug this hole by using that x over here. All right. This goes, now we take the limit. This goes to 1 because I've got junk over sine junk, times this goes to 1 because I have sine junk over junk, times, and now this is 1/5 times 3/5. I mean, sorry, 1/5 times 3, which is 3/5. The answer is 3/5. Now, I know Dilpreet's going to tell me, well, I knew that answer because that's 3 over 5. And so that was our answer, 3 over 5. I'm with you. It won't always work, though. And you know what? I mean, I can give you an example. That's no problem. But when I'm looking at your work and I'm grading your test, this is what I want to see. I mean, a student who can do this and kind of like unravel this is showing me a much higher level thinking, than just trying to find a pattern, right?